Now see, it's the capacitor. The property is called capacitance. Welcome to the new lecture series. And the first lecture is only going on. Here we will discuss about the calculation of power and then the work done for the passive element of the capacitance. So what is capacitance? Capacitance is nothing the property of virtue of which material by virtue of which it supposes a change in voltage, okay, which is denoted by C, and the property is known as due to capacitance or capacitor. This is the mainly the structure. It's the symbol for representing the capacitor. Okay, let us take a capacitance having the source voltage V of the I current which is flowing through the conductor, and the voltage across it is Vc plus in every situation, every circuit of the inductor and capacitor and the resistance, what we have taken that the current is always flowing from the positive to negative terminal, as well as we have already discussed in the scenario first that in case of the active element or the sources, the current in the situation the current always flow from the higher to lower, that is positive to negative terminal, that is from the inductor, capacitor and resistance, because it's consumed. Okay, no? So let us assume it's the capacitance is C1. Okay, now here let us assume, let's take a tank. Okay, this is a tank. This is a tank. Okay, it's voltage potential, and let's Q charges in between. Okay, Q charges is in the tank. Okay, now capacitance is parameter of conductor mainly. Now let us see what is I from the previous equation. It is the rate of flow of current, rate of flow of charge, of course rate of flow of charge, that is dq by dt. Okay, and here it is Q. You know, Q is directly proportional to V. More the V, more the charges. More the V, more the charges. So directly proportional to V. For removing the constant, we just keep CV, and from this equation, this one, if we substitute the value of I, what we get? dq by dt, that is nothing but I equals to dCV by dt. We will get on differentiation what? C dV by dt plus V dC by dt. We know that from the previous that this will be possible when temperature is constant, and we know that dC by dt is 0. This term will be 0 for time invariant capacitor. Okay, so I equals to C dV by dt. This is the one formula. Now dV is what? dV equals to C 1 by C I dt. Okay, dV equals to 1 by C I dt, and if we calculate the value of V, that is 1 by C integration I dt. So this is the, and unit is volt. Okay, now see, we have got this one. Substitute, if we calculate the power and the work done, we will substitute the value of V and I mainly. Now for power calculation, we know that power equals to voltage into current, where V equals to 1 by C into I dt, okay, into I. Okay, okay, that is nothing but I square dt is 1. But if we substitute the value of v, what we will get? P equals to P or I. Let us suppose we have already substituted the value of v. So now we substitute the value of I. Okay. Now B C dV by dt, which is the power. And it is power. The SI unit is what? And this is nothing but the instantaneous power. We can also write P equals to CV dV by dt. Same. Okay. Now this is for the power calculation. If you want to calculate the work done, we know that the work done is nothing but work done is the rate of doing work. Rate of doing work is called power, mainly. If you want to calculate the work done, that is nothing but integration of P dt. बैक में तो जाना पड़ेगा बताने के लिए, रुक जाओ. देखो, पावर इज नथिंग रेट ऑफ डूइंग वर्क एंड P dt equals to d/2 and work done equals to integration of P dt. यही ना, यहीं से आया, ये चीज ले रहे थे हम. Now see, if we substitute W equals to P dt, P dt. Power is how much? BC dV dt. Work done equals to integration of power. Okay, if you substitute the value of P equals to VC dV dt into D, what will you get? Integration, differential, cancel out, you will get this one. You will get this one. Okay. Also, P equals to CV dV by dt. CV dV by dt, this one from this one. Okay. We can substitute the value of, but after this one, what will we get? D by dt half CV square. Okay, this one is also one formula. We know that W equals to integration of P dt equals to integration dy dt half C square dt. Okay. This is what we have done. We have done nothing. We have put the value of power mainly. We have put the value of power. Okay. The CV dt we can write in this way. Okay. We'll get this one. Or finally, we can write it using the form this half CV square integration minus infinity to t. This is for the capacitance. Or W equals to half C V2T square minus V. is the important formula. If the initial voltage is 0, if this is assumed as 0, then what? Then V infinity is, if the initial voltage is 0, then 0 volt. Why? This is 0. Initial is 0, na? If we take the initial voltage as 0, initial voltage is V initial is minus infinity to 0. If we take this 0, then W will be, work done will be half C V square, or with respect to wherein T, V square T equals to thing. But the instantaneous energy, it is the instantaneous energy, it is the total energy. When is the total energy? Now see the QV characteristics. If we plot the characteristics, we know that Q equals to CV. Let's change the marker. Q equals to CV and C equals to Q by V. If we compare this one from Y equals to mx, so C is constant, of course, follow in this direction, so it is only slope will be C, and this is nothing but minus Q plus Q minus V plus V. The line is passing through origin, so it is linear. Okay, it is same as R, but in QB plane. Okay, so okay, now this is offer. We'll see the next lecture, the relation between the voltage current between L and C circuit.